Okay, ready?
Okay, sir, start, sir.
Hi, welcome to this particular demo class. Again, this is a demonstration class where we will be actually showing you the demo, and this time we have taken an actuator. Last time, if you see, we were talking about a sensor which was pressure sensor. So, when you have seen how he is applying the pressure and how can you see the change in the resistance or a voltage depending on what the parameter was. And again, you understand that pressure sensors are of several type. The one can be of resistive type, second can be of capacitive type. So, you need to understand that their signal conditioning units would change depending on the type of the pressure sensor. In this class, our focus is more on the actuators, and we will show it to you as a demo how to interface stepper motors with microcontroller, so that you get understanding that if you have an actuator, how can you use a controller to actuate this particular stepper motor. It is a short demo. However, since we need to start from scratch, we have tried to put the details about what are the stepper motors or what are types and how you can interface it, how can you control or program the controller. Arduino is just one controller, but there can be many, right. And later on, if you really see the signal conditioning modules, you will see that there would be lot of parts of a controller that we may not like to use it. In that case, what can be alternatives? Alternative can be something like PSOC. So, when you look into the parameters, you will know and understand more about what can be the alternative techniques of interfacing the controllers with the sensors or an actuator, right. So, just look at the demo, have any question, feel free to shoot me an email or ask me through the forum, and I will get back to you. Bye.
Hello, welcome to the Sensors and Actuators course. In today's session, we will be seeing about an actuator which is called as the stepper motor. Okay, so we must have discussed earlier about other actuators such as DC motor, peristaltic pump, then so apart from other sensors also. So in this tutorial, we will be showing you how to use a stepper motor, which is a rotatory actuator. So this is a different kind of motor, as you can see on the presentation. So stepper motor is a different motor, like our DC motor only. You can see a stepper motor, a type of stepper motor named as NEMA 17 stepper motor over here. Okay, you can see this black part with a black part is the body, and this is the shaft that rotates. Okay, so this is the stepper motor. This is an example of a standard stepper motor that is commercially available. Okay, so what exactly is a stepper motor, that we will be discussing now. Okay, you can see that this is the inside of the stepper motor. These two pictures over here, the figure 2 shows the inside the construction of a stepper motor. You can see here that there are coils over here, correct? You can see coils. Okay, you can see here coils here. Okay, and there is something on the center, a circular shape on the center, and this is like the view from this side. Okay, that is okay. If I call it the top view, and then this is the view like out of this paper plane. Okay, so this is over here, and you can see something over here also that has a cylindrical shape. You can understand from the figure only, and this entire part is what that is going to sit inside this. Okay, so you can see a motor case on the outside, correct? You can see a motor case. You can see 4 wires, one green one, blue one, red one, and black one coming out of the motor, correct? And you can see coils here, 1 2 3 4 5 6 7 and 8 number of coils wound around, correct? And it is fixed to the motor case, right? And there is a circular thing on the center, and which is shown over here, correct? So this is the construction. Now I will tell each one of what each one of them are. Okay, so these coils are called as the stator coils. Okay, these are called the stator coils, and this is called the rotor. Okay, and what there is in the center is the rotor. So as the name says, the stator coils are stationary, and the rotor rotates. So rotor consists of the part that rotates inside the motor, and stator coils are the fixed stationary part of the motor, okay, and this rotor will be having the shaft that is over here, okay. So the shaft comes out through this rotor hole, okay. This is how it is constructed, and I will tell you what are the how it works, okay. And you can see here on the right side, this is the construction of a rotor. So it has a shaft, okay, it's written magnetic shaft. I will tell you how it is magnetic and all in the later stage. So you can see the shaft here, okay. You have rotor poles. So the stator coils are wound on the stator poles, and there are rotor poles also, okay. These poles, as mentioned here, are made up of materials such as, okay, soft iron, or soft steel, okay. These are magnetic materials, okay. These are magnetic materials, generally paramagnetic materials, okay. So these are these shafts are made up of soft iron or soft steel. There are different types also. I will let you know once we discuss further, okay. So what happens is, okay, you can see there are two coils, 4 wires coming here, and each two of the wires will be connected to two or more stator poles, okay. Before going into that, I will show you how a stepper motor works, and for which I will be going through different types of stepper motor so that you can get a better understanding, okay. So before that, I will say that the principle of a stepper motor works on electromagnetism, like most of the electric motors, okay. It works on electromagnetism. It means that when electromagnetism is nothing but when electricity passes through a current carrying conductor, a magnetic field is generated, and this magnetic field will be able to create some force, okay, and which will be used to rotate the motor or any purpose. So based on electromagnetism, the stepper motor will give a mechanical rotary output, okay. And the good things about the stepper motor are they are brushless, okay. They are brushless, so the contact losses are very less, okay. The contact losses are very less, and it's synchronous. It means that whatever signal we give at a stipulated time, or whatever signal that we give right now, it is going to affect the motion of the stepper motor, okay. So it doesn't have any delay or lag, okay. So it's synchronous, and it has a soft iron or magnetic rotor shaft, okay. Soft iron or magnetic rotor shaft. I will give you an idea about it. And CNC machines, 3D printers, which are popular these days, use stepper motors. Also, I have shown you micro manipulators. These also use stepper motors inside it. Then why stepper motors? Okay, I will tell you. So consider this is the shaft, top view of the shaft, okay, and I am just drawing a circle here, and I am putting something like a line here, okay. And what happens is when the rotor rotates or the shaft rotates, this line is going to like come or rotate like this, right? This line is going to rotate about this shaft right here, and it's going to complete a rotation. In an ordinary DC motor, what happens is it's like a continuous motion. So it's like keep on rotating, okay. It will keep on rotating. But in a stepper motor, it happens in steps. Like this is the shaft, okay, and this was the line. It will rotate and come over here first, then it will come here, then here, then here, then here, then here, and here, and it completes a rotation. Though I showed it like 8 different motions, it's actually very continuous in the sense once we give the signal for rotating it, it will rotate in steps, but the steps will be close enough that we will not feel like it is going like a step by step motion, but it will be continuous only. But this is how it works, okay. Now before going to further this thing, I will go to the next slide where I will show you different types of stepper motors, okay. So there are different types of stepper motor, and we classify them based on type of the rotor. Based on the type of the rotor, we can classify them as permanent magnet stepper motor, variable reluctance stepper, and hybrid synchronous stepper. So you can, what you can see here is, this is the permanent magnet stepper motor. Now I will tell you the concept of how it works. So you can see here, there is a winding A here and a winding C here. Winding A and C, and you can see that both of them are color yellow here and both sides, right? And there is another stator B here and a stator C, D, which are also having the red color windings, correct? So it's like the cable comes, there were 4 wires, right? It will be like the cable comes, it will rotate about this stator pole, it goes here, it will rotate about this and go out. So what happens is, one coil, say the green one that we saw in the previous slide, the green one, the green and blue are, I am just telling you an example, green and blue are close and red and black are close, right? So I will say the green wire over here will come here, rotate around the pole, go to the other pole, rotate around it, and will go out as, say, blue wire. And similarly, a red cable will come from here, it will go about this B pole and come out as the black wire. So what happens now is, when I create a magnetic when I pass the electricity through the coil G, G, or the wire G, then as you can see here, when I pass through, say, G, it can be connected, it will be like, it will be, this wire will be connected over here. So this is a different motor, but you can see here that individually, like when I power this send current through this pole, through this coil, then this pole will be magnetized. You can see it will be turning blue and red, right? Blue is the south pole and the N is the north pole. So what happens is, the shaft over here will also have a magnet in it. This is an example of the permanent magnet stepper motor. So it will have a north pole as well as south pole permanently on the rotor shaft. So what happens is, when I pass current through one of the coil, what happens is, here if there is a south pole, if there is a south pole created here, then what happens is, this south pole will attract the north pole of this motor, correct? This south pole and north pole will be attracted, and they will align so that they will be close to each other. So this south pole and north pole are attracted now. Similarly, if this coil is continuous over here, then there will be a south pole, there will be a north pole created here and a south pole already here. So this will also be attracted. So now this shaft or the center line of the stepper motor's rotor with the magnet in it will be aligned with the poles, correct? So it will be like in a straight line. Now what happens is, this is what happens when I pass current through G and it comes out through the blue line. Now suddenly I change the magnetic field by passing the current through B and through the black and leaving it out through red. What happens is, this will magnetize, right? So this north pole will be attracted to the south pole generated over here, since we switch it off, switch the current going through here and divert it through this coil. So this north pole will be attracted towards the south pole and the motor shaft will rotate. So you know how it works now. So if I change the polarity here, the motor shaft which was here will go here, then will go here. So it can rotate a complete circle by means of 4 steps. So this is how a permanent magnet stepper motor works. So now you can see back here. Here you can see that there is a permanent magnet in the center over here, correct? And when I pass current over here, so this is the permanent magnet over here, and this is the coil. So I am passing current through this. So this will be magnetized and it will attract initially. Then I suddenly switch the current and make it flow through this, and the magnet will be attracted here. So this is the method by which the stepper motor rotates. Cool. So, this is how a permanent magnet stepper motor works. Permanent magnet stepper motor works. Similarly, there is another type of stepper motor called as variable reluctance stepper motor. Okay, variable reluctance stepper motor. Reluctance is similar to resistance. Okay, resistance is the opposition to the flow of current, but reluctance is the opposition to the flow of magnetic field. Okay, to the flow of magnetic field is what reluctance is. So, what happens is whenever we pass current through a copper coil or any other coil or current carrying conductor, a magnetic field is generated, right? And this magnetic field, so if I pass the current through this, the magnetic field will go like this, right? You must have studied in the lower classes, correct? It will be a magnetic field will be created like this, correct? This is what generally is. So, what happens is in this case it will be connected like the center of the magnetic field will be going and a big magnetic field is created. I will show you. Okay, I am just erasing it off. So, if a magnetic field is going through the center of this coil like this, it will go infinitely and there will be another field generated like this. Okay, there will be smaller fields also inside. Okay, so if magnetic field is generated like this, this rotor shaft over here will be acting such that it will always try to reduce the resistance or reluctance in the path. Okay, so the magnetic force field has to pass through this soft iron material and reach and go through this coil and complete the loop, right? The magnetic field has to complete the loop since magnetic fields are closed loop. Okay, so it will always try to reduce the resistance or the reluctance. So, what happens is if it is not aligned, if the shaft or the soft iron core here is not aligned, then the reluctance will be more. So, what happens is this shaft will the rotor will be experiencing a force, a magnetic force that will try to align it to the center of the coil or the center of or the axis of the magnetic field, so that the reluctance will be minimum. So, it will also cause the rotor to rotate. Now, if I switch the current flowing through it, the magnetic field will be generated in this axis, okay, and the shaft will rotate again. This is how a variable reluctance stepper motor works. This is how a variable reluctance stepper motor works. Then there is something else called as hybrid stepper motor, which will have both permanent magnet inside it. Also, there will be poles. Here there are soft magnetic poles, right? Similarly, we will have soft iron poles. So, these stepper motors will have the advantages of both permanent magnet type and the variable reluctant types. So, what are the positives and negatives? It is like since the stepper motor over here in the permanent magnet is here. So, the magnets are already fixed, the permanent magnets are already fixed. So, what only we can do is like we can change the current flowing through it, correct. So, if there will be limitation to the number of magnets we can keep as well as the which will affect the resolution or the number of steps it can move or how fine we can move. So, since these stepper motors are widely used for applications such as 3D printers, CNC, we need them to move very precisely, very accurately. Okay. The NEMA 17 stepper motor that we showed here, right. So, it has 200 steps per revolution, okay, 200 steps per revolution. That means each 360-degree turn will be divided into 200 steps, approximately equal to or is equal to 1.8 degree. So, this stepper motor can rotate up to 1 degree steps. Okay. So, its accuracy will be like can rotate like this small, okay, or even smaller than this. So, to rotate a 90 degree totally, it will have to rotate how many times? It will have to rotate like 50 times, correct. For rotating 90 degree, it will have to move 50 steps, correct. 50 steps it has to move to complete 90 degree, and to complete 360 degree it has to go like around 200 steps. So, this is how a stepper motor works. So, there is some other concept also that I will explain to you. So, this is how a stepper motor works. And now we are going back to the another type. We can classify based on the winding also, by which we can classify them as unipolar and bipolar. This is the circuit of the unipolar stepper motor, and this is the circuit of the bipolar stepper motor. Okay. So, what you can see here is this is the same motor. Okay. It will have 3 wire inputs. Okay. 3 wire inputs. One is coil end 1 and common wire, and a coil end 2. Okay. And there is the other coil for magnetizing the rotor, say it is there. Then what happens is, if I pass current through coil N1, it will be going out through common wire. Okay. Common wire is like the ground. So, the unipolar motor has 3 wires. If I pass current through the coil end, it will come out through the coil wire, common wire, which is kind of a ground, and the stators will be able to rotate in one direction, correct? Or the magnetic field will be created in one direction, and if I swap the current and current flows through the coil end 2 and goes out through the common wire, the magnetic field direction will be reversed. So, in this case, to reverse the direction in which the motor is rotating, what we do is we change the direction in which current flows, or by we will change the input coils. Okay. That is how we control the direction. And in case of a bipolar stepper motor, it has 2 independent coils, A1 and A2 and B1 and B2. So, if I flow current in one direction through A1 and A2, the motor will get magnetized in one direction, and if I send the current in other direction, then it will rotate in the or magnetic field will be created in the opposite direction. So, the main advantage of the stepper motor, the bipolar stepper motor, is that it will have higher torque. It is because 2 independent coils are there which could be connected to multiple stator coils, but 2 independent coils, and the current entirely flows through the entire length of the coil. The entire length of the coil current flows, and the magnetic field will be stronger. But in this case, the current flows only through the half length of the coil, so the torque is actually less. But the easy thing is, using a simple transistor circuit, we can actually switch the direction of the magnetic field in case of a unipolar thing, using a simple transistor switch. Using a transistor switch, we are able to switch the direction, but in this case we need some delicate mechanisms such as an H bridge, okay, to properly switch between the lines and make this motor rotate. Okay. So, this is the 2 types. The classifications are based on rotor, we can classify them as permanent magnet stepper motor, variable reluctance stepper motor, and hybrid synchronous stepper motor, while based on the type of winding we can call them as unipolar stepper motor and bipolar stepper motor. I think you have got an idea. Okay. You can see a lot of YouTube videos that will explain it to you with more animated videos like that is shown here. Okay. So, now I hope you understand how a stepper motor works, and you can see here I have given an equation, step angle is equal to 360 by number of poles. Okay. So, more number of poles means we can create magnetic fields in that many direction, correct. If I have 4 poles like this, then I can create 1 and 2, correct. 1 magnetic field in this direction, 1 magnetic field in this direction. If I have 4 more poles, then I can create like, see. So, I can increase the step. Here I can get a 45-degree precision step, while in the previous case we can only get a 90-degree thing, correct. If I increase more number of poles, what happens is we will be able to get more accurate poles or number of steps and reducing the step angle. Okay. The step angle can be reduced if we increase the number of poles. Now, there is some other method that we do it electronically. So, this is the constructional aspect of the stepper motor. So, we may not be using it exactly like this. So, we could also use it in some other way by electronically controlling it. So what we does is we can pass current through two different coils or two different stator coils at once, by which there will be a magnetic field in this direction as well as magnetic field in this direction. So what happens is the resultant will be like this and the motor will align like this. So here you can see that if we polarize only this one, the motor would have aligned like this. If we align like this, one second. So if we align these two motors, the motor will align like this, correct? If we align these two stator coils, and if we pass current through these two stator, the motor will align like this. But if we power both of them together, there will be a resultant and we can stop the motor like this also. So by means of electronically creating an artificial pole is created here, based on which we can get an extra step. This is called as micro stepping. This is called as micro stepping. So micro stepping is used for higher precision activities. It is called as micro stepping. So for this we do this process by using an external electronic circuit or something like a motor driver, and which will help us do micro stepping. Okay, micro stepping is nothing but using the same stepper motors by exciting two coils at once, we are able to get micro steps. Cool. Okay, now we will see the working of the stepper motor. Okay, so you can see here you can see the stepper motor over here, correct? This is the NEMA 17 stepper motor and I have got an SMBS here. This stepper motor requires 12 volt power supply for it to work. So I have connected a SMBS that can provide an output of 12 volt. Okay, and it goes to a board over here. This is an Arduino Uno board on the bottom and this is a CNC shield. So what are CNC shields? CNC shields are nothing but shields generally are some mountable electronic circuit. Okay, Arduino boards are standard. So if we are going to use an Arduino Uno as a CNC machine, then what we can do is we could use a standard Arduino shield. Okay, so using a standard Arduino shield which can be easily plugged in, we can use it for different applications. So in this case we are using this as a CNC shield. Okay, so we are using a shield that is used for such application. There are different other shields also. Some line follower robots use a shield for that purpose. It can be like take an Arduino Uno, take a shield, insert it, so the circuit is ready. Automatically the wires are all connected by PCB manufacturing. Okay, so we do not have to use any breadboards or we do not have to custom design any circuits. So shields are widely available for different application. So what we have used here is a CNC shield. This CNC shield, Arduino CNC shield, can control up to around 4 to 5 stepper motors. Okay, we can control up to 5 stepper motors. Okay, so now what I will show you is a motor driver. Okay, the CNC shield uses different motor drivers. It's like a circuit, like a breadboard, so which is all like hardwired, and this one, this is a motor driver which will be mounted still on above the Arduino CNC shield. So this is a A4988 motor driver. This is a A4988 motor driver. So what it does is it takes input from the Arduino board and it will give an output to excite the coils inside the stepper motor. Okay, so the input of the driver is two simple signals. One is pulse and the other one is direction, or we also call it as direction and step. Okay, step is like, okay, turn one step, another step, another step. So it's like steps, and the other one is direction, clockwise or anti-clockwise. Okay, and in case of Arduino we can do it in only two ways. It's like high or low. High means it will rotate in one direction and low means it will rotate in another direction. So, there will be two input to the motor driver over here. It will be direction as well as step, and direction can be high or low, okay, or anti-clockwise or clockwise. But the output we will be sending from the Arduino to this one will be high or low, and it will understand that it is to swap the direction, and the other one is like we will be asking it to move steps, and for which we will be using pulses. Okay, I send one pulse. Pulse is something like you can see here. Okay, see, okay, I am just creating, see, if I create this much, okay, you can see this is a digital pulse. Okay, this is a digital pulse. So, if the clock cycle starts here, okay, so there is a low area here, then the it goes up, okay, comes down here, okay. Now, once entire cycle will be completed here, correct, or if we count it from here, it will be like here low. So, there is a high and there is a low for a certain duration, correct. There is a high and a low for a certain duration. So, this is a pulse. When the motor driver A4988 gets a single pulse, what happens is it will count it as one step. So, you send a pulse, okay, a single pulse, it will rotate one step. If you send another pulse, it will rotate another step, and based on the direction pin or the direction signal that you have given already, it will be changing the direction also. So, you can change the direction as you wish, and also you have to continuously send a pulse for it to rotate. So, why it is important is if you send 200 pulse exactly, or if you send 200 pulse exactly for this NEMA 17 stepper motor, it will rotate 200 steps, and that is equal to 360 degrees. So, it is like perfectly accurate. You send 100 pulses, then it will rotate 100 steps equal to 180 degree. So, it is like pretty accurate, and also by means of putting some or shorting some pins in the CNC shield, this A4988 even allows you to use up to 32 microstepping. 32 microstepping means one step, that is around 1.8 degree in case of the NEMA 17 stepper motor, can be further divided into 32 smaller steps. Okay, so that accurate kind of motion will be available with the A4988 motor driver and this CNC shield. Okay, I won't be showing you the microstopping feature of the stepper motor, but I will be showing you a sample demo of how to control a stepper motor. So, you will get a lot of tutorials and other things, so you could just study from this. Okay, so we will go to the Arduino code now. So, you can see the coding screen now. You can see the coding screen, right? Yeah. I will increase the font a bit more, say hi. Okay, cool. So, you can see now. So, as usual we have a void setup, right? Yeah, we have a void setup over here, correct, and above which I have defined X step pin. So, as I said, there is two input to the stepper motor or the stepper motor driver, that is A4988 that we have used here. There are a lot of other motor drivers also. This A4988 has a current carrying capacity of around 1.8 amperes. So, if you are going for a higher power stepper motor, you can go to use some other motor drivers. Okay, and there will be plenty of heat generated when we use this stepper motor drivers, and every one of them will have a heat sink also to transfer this heat into the air. Okay. So, you can see here the two inputs to the motor driver are step pin and the direction pin. So, in the step pin you have to give the pulses, and in the direction pin you have to give either high or low to control the direction of the motor. And there is an enable pin. I do not think you have to care about that now. Enable pin is actually used to use for the CNC shield. The CNC shield is created such that if we for enabling the stepper motor, okay, enabling the stepper motor, say as I said, this shield can control up to 5 stepper motors, X, Y, Z and an extruder one. So, since this is a CNC shield, okay, for it can be used for 3D printers also. So, as I said, that's why we denoted X. So, I am connecting the stepper motor to the X motor driver, or the motor driver assigned to the X. Okay. So, that pin is pin number 2 and pin number direction is pin number 5, and if I need to use that pin stepper motor connected to the motor driver X, okay, I have to enable it and keep it as low. Okay. If I keep the enable pin low, then only I will be able to control the stepper motor. It is done because see, if the stepper motors, if we supply power to it, it will be powered on and the magnetic field will be created, but only when we give the second pulse it will start rotating, but otherwise it will create a holding torque, like a single pole will be magnetized completely, or it will remain magnetized and it will prevent the motor from rotating. So, it is actually taking some power, correct. So, when we are not using all the stepper motors, we need not waste our power. That is why we have this feature. You enable it low only when you create the enable pin low only when you need to rotate it or power it up, otherwise keep it high so that it will not be powered up. Okay. Cool. So, the step pin is 2, direction pin is 5 and enable pin is 8. Okay. This is specific to this motor driver. Okay. Now, inside the void setup I have started serial communication. It is not very important here, I have not used it, and in the pin mode X should be an output, since its X enable pin is an output, and I have made it low, so that I want that motor to rotate completely. I am not going to change it anyway, and pin mode X direction pin comma output, step pin comma output, you know this already. Okay. So, for creating a pulse I have used a symbol method. Okay. I put an integer X. Okay. I have put an integer X and digital write 5 comma high. 5 is nothing but X underscore direction pin, right. So, we already defined it like that. So, if even if we call it like that, we define like this, it should be working, correct. And what we will be doing is, I have put a for loop here with x equal to 0, x less than 200 and x plus plus, you know their for loop. Okay. Now, I am going to create 2 comma high, or make the second pin high. Second pin is nothing but the X step pin, correct. X step pin, correct. Yeah. So, if I make the step pin high, okay, initially if it was low, okay, it will be low, and then I delay for 5 millisecond, then I make it low and delay for 5 millisecond again. So, I have actually generated a pulse. I will write or show it here in the screen. Okay. So, this pulse, okay, for 5 millisecond it, okay, you can see here, actually this is a better way. I have made it high for 5 millisecond, I have made it low for 5 millisecond. Once that is done, the for loop will come again and will again make the pin high. So, this is how a single pulse is generated. So, every time the for loop goes for a next iteration, a pulse is generated, and how many times it will happen? It will happen 200 times, from 0 to 199, correct. 0 to 199. So, what happens is, it will rotate 200 steps inside this for loop, then it will delay for 1 second. So, the motor will stop again, then again it will start from the first part. Okay. So, the motor will be rotating 200 steps or equal to 1 rotation, then it will stop for a while around 1 second, and then it will again start rotating. Now, we can see what happens when I upload the code. Okay. You can see the stepper motor now. I am uploading the code. Okay, I have uploaded the code now. Okay. It is uploading. Okay. Yeah, its uploading is done. Now, you can see that the stepper motor rotates. Okay. It will rotate and comes to stop. you note this initial position. Okay, you see my finger is over here. Initially this black mark over here is here. It will exactly come there, correct? See, so it's rotating 200 step exactly. Every time it will be like this. So this is how a stepper motor works. I told you how it works. This is a bipolar stepper motor. You can see there are 4 cables, so it's a bipolar stepper motor. So from the Arduino it will get both direction as well as step, and the motor driver will convert and accordingly switch the coil and change the magnetism. So this is a stepper motor works. So I hope you understood this session on how stepper motor works. So there are different type of stepper motors which can be used for different other applications. The very common application that we see today or these days are the 3D printers. So the 3D printers will be using like 5 stepper motors to control the X, Y, Z movement, as well as the extruders or extrude the plastic out. Okay, so there are like wide applications. So this is how a stepper motor works. You can use and try this using different motor drivers. You need not use a CNC shield, but this is a easy way to do it. You can even create a circuit of your own and try it out. Okay, so that's it about the stepper motor demo. Thank you.